Now, let's focus on the position of a point. This requires a numeric location for each dimension that we get interested in or the context demands. A point on a number line. That means we are interested only in moving around a number line. So to figure out a particular point, we just require one number for identifying the location. Okay, a point on a plane. Now remember, a plane is two-dimensional. Yes, so for this we require two numbers for identifying the location of a particular point. Now a point in space, that is three-dimensional, requires three numbers for location of a particular point. Now we have already seen this, that the dimensions are orthogonal or perpendicular to each other. So when we are talking of a number line, we have a starting point, that is 0, and we have numbers to the right and numbers to the left. To the right we treat it as positive direction, and to the left we treat it as negative direction. Similarly, when we want to focus on a plane, then we have positive and negative just like a number line, and then we have a up and down direction as well, right? So this is positive, this is negative, this is positive, this is negative. To find a particular point, we require two numbers: how much distance we have to travel to the right or left, and how much we have to travel to up or down. Okay, now when it comes to the third, and remember here it is perpendicular. Now this is called the x-axis, this is called the y-axis, and this we can name it as x dash, y dash, or y prime. And origin is usually treated as O. Okay, now when we want to look at three-dimensional, what do we do? Now remember, we are trying to draw a three-dimensional thing on a two-dimensional surface, right? So you have to bend your mind to follow it. So something like this. Remember, this particular line is going into the, right, behind the sheet, and this is coming in front of the sheet. So which means that this angle is again 90 degree. This is also 90 degree, and this is also 90 degree. Let's say this is x o x prime, y o y prime, and z o z prime. Okay, so this is, and here to identify a particular location we require 3 points. How much distance we have to go from along the x-axis, how much distance we have to travel parallel to y, and how much distance we have to travel in the direction of z. What we have seen till now is the lines x o x prime, y o y prime, and z o z prime are called rectangular Cartesian coordinate axis. X-axis, y-axis, or z-axis. O is called the origin. Now let's look at another aspect. Space is made up of infinite number of planes stacked together. A plane is made up of infinite number of lines stacked up, one beside the other. A line is made up of infinite number of points put beside each other. Okay, now here another thing, important thing you have to remember is that when I say stack together, since we are talking of space, think of it like something like this, right? So here you have a box kind of thing, right? I'm just showing you a part of the whole thing. Okay, let's take it like this. Okay, like this. So it is in 3 dimensions. So it's as good as saying boxes stacked on each other in all directions. Whereas here, think of it like our graph paper, right? So we have lines like this and also lines like this. Whereas here it is just points. Okay. Now, since we are talking of 3-dimensional, this one, remember the plane containing the y and z axis is called the YZ plane. The plane containing the z and x axis is called the ZX plane, and the plane containing the x and y axis is called the XY plane. Now, these 3 perpendicular to each other planes, that is XOY, YOZ and ZOX, are called coordinate planes. Now, remember, in a 2-dimensional, this one, the coordinate system is made up of 4 quadrants: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Yes, so the plane is divided into 4 quadrants. Similarly, when we talk of a 3-dimensional, here you have to visualize it a little bit. Let's say this is X, this is Y, this is Z, right? Now here let's focus on above the x-axis, right? Here can you visualize that there are 4 quadrants, one in front, one behind, right? One in front, one behind. Similarly here also, one in front, one behind, one in front, one behind. So 4 and 4 below the x-axis. So there are totally 8 divisions of the entire space. Now these are called octants. Just like we had quadrants, we have octants. And the space that is used, or the space bounded by the positive directions of x, y and z, is the first octant. Okay, this is the origin. So first octant is the region bounded by OX, OY and OZ. Now remember, in a 3-dimensional space, a point requires 3 numbers for location. This is called the coordinates of the point. Again, we use a capital letter. So we can say P, 2, 3, 1. Right? This is the location of a point called P. So that means we have to go 2 steps in x direction, 3 in y direction and then 1 in z direction. Now the three axes are called the axis of reference. Okay, in general we can put it like this: x, y and z. X is the directed distance from YOZ plane, right? Remember, this is x, let's say this is y, and this is z. So this is what plane? This is YOZ plane, right? So from there, how far away it is? Away from the YOZ plane. Similarly, directed distance from XOZ plane. So from here, how far away it is? And similarly, directed distance from XOY plane. Okay, a few more things. If the point is on the x-axis, which means something like this, right? It is here, it is on the x-axis, this point. So the point is on the x-axis itself, which means that for x there is a value, but for y and z the value is 0. So the coordinates of such a point is going to be a, 0, 0. Now if the point is on the y-axis, then the coordinates would be 0, b, c. And if the point is on the z-axis, then it will be 0, 0, this should be 0, c, right? Now that is one aspect. Another aspect is, if the point is on the YZ plane, here we are talking on the axis, here we are talking of on the plane. So if it is on the YZ plane, that means x equal to 0. So which means the coordinates would be 0, b, c. If the point is on the XY plane, that means z is equal to 0. So which means the coordinates would be a, b, 0. Similarly, if the point is on the XZ plane, that means y equal to 0, which means the coordinates would be a, 0, c. Now to be able to visualize this in your mind, I would suggest look at the corner of a room, right? Although you will be able to see only the first octant kind of thing, but I think that would be really helpful. So look at the corner. No, it will not be like this. You will not be looking at it from that side. You will be looking at it from this side. So this is the corner. Treat this as origin. And now try to figure out where the various points would be. Room, right? So something like this it will be. Okay. So if a point is somewhere in the middle of the room, then you have to go in x direction so many steps, in y direction so many steps, and the point may be so many steps above the floor. Okay. So that is one part of it. As we have seen, a point, let's say x, y, z in space, right? See, the moment you see the word space, understand that it's going to be a three-dimensional coordinate system. Now, when we talk of a point, yes, one way of referring to it is by talking in terms of x, y, z coordinates. The other way of looking at it is using vectors. or in terms of position vector, right? So that we refer to it like this. Let's say R is the position vector of P, X, Y, Z. And this is the position vector of, let's say, P with respect to O, that is the origin. And I, J and K are the unit vectors along the X, Y and Z axis. So something like this. Let's say this is Z, Z prime. Let's say this is origin. So this is Y, Y prime. This is okay. Now there is a point here. It is in front, right? So what we are going to do, this is X prime and this is X. So this is origin. So here we are going in the X direction some distance, and then from there we are going some distance in this direction, and then some distance we are going in this direction, right? So in X, Y and Z directions we are going, and this is the point. So let's say, let's give some names to these points. Let's say this is R, this is Q, and this is point P. Now OR is equal to X. RQ, this is X, this is Y, and QP is equal to Z. Now if we have to convert it into vector form, what do? We say OR is equal to X in which direction? In the direction of the unit vector I. Okay. RQ is equal to YJ. QP is equal to ZK. This is the magnitude and this is the direction. Now, purely based on vector arithmetic, remember this is what? OP is what? OP is going to be a position vector of P with respect to origin. Now we know OP is nothing but the sum of all these other vectors. So that would be OR plus RQ plus QP, or we can also write it as XI plus YJ plus ZK. Now here in this form, X, Y and Z are called the resolved parts of R. The resolved parts of the vector R. Now from the figure itself, we can make out certain things. We know OP square is equal to OQ square plus QP square. Pythagoras theorem. Okay. Now OQ square in turn, OQ square can be looked at as OR square plus RQ square plus QP square. Right? Now OR square is nothing but X square, RQ square is nothing but Y square, and QP square is Z square. In terms of vectors, OP is nothing but the magnitude of this vector. Basically what I'm doing is I'm taking out this and putting a square root here. So I'm left with OP. Now this OP is nothing but the magnitude of the vector OP is equal to x square plus y square plus z square, which is nothing but the distance from the origin to P. There are a lot more things that we are going to look at with reference to a point and combination of more than one point as we go along. I think enough for today. Bye for now.